Welcome to the Virtual Venture Cafe, everyone. It is our Defense Innovation Conference. I would like to extend a very special welcome to our first-time community members. As you all may know, Venture Cafe is a nonprofit organization. All of our programming, which we produce weekly, is free and open to everyone in the community, wherever you're coming from. This is all made possible by our corporate partners, corporate innovators, just like BAE Systems, who are supporting us today. So thank you very much, BAE Systems. Thank you for bringing this content to us today. We will not be using the chat function or the raise your hand function this time, but if you have any questions, please just type them in the Q&A. And with this, I would like to introduce Bahare Haji Saeed, who will be moderating the discussion. Dr. Bahare Haji Saeed is the Director of External Engagement in Tech Scouting at BAE Systems Fast Labs. She joined the organization in November of 2017 as a Technical Development Manager, and prior to joining the organization, she was a government civilian working at Hanscom Air Force Base. Bahare earned her PhD in Electrical Engineering from the University of Massachusetts Lowell in 2006, and with this, I am happy to hand the session over to you, Bahare.
Thank you, Yulia. Good afternoon, everyone. Welcome to the 10th Venture Cafe event sponsored by BAE Systems. This is part of our series on defense innovation at startup speed, which we launched in 2018. Again, my name is Bahare Haji Saeed, and I am the new Director of External Engagement for Tech Scouting Division at BAE Systems Fast Labs. We would like to thank the Venture Cafe team for organizing this event and its strong support over the years. At BAE Systems, we are committed to innovation and delivery of new advanced technologies to the defense and aerospace market through collaboration with small businesses and government labs, universities, and other corporations. The Tech Scouting Division facilitates these external collaborations at BAE Systems. We identify external commercial technologies that can rapidly transition into our complex systems and leverage funding from government and venture capital to further mature for tech transfer. We adopt a new approach that creates a new environment for small high-tech companies with new opportunities and business models that enable them to rapidly become suppliers to the defense market. If you are an entrepreneur or small business owner with groundbreaking technologies with possible applications to the defense and aerospace market, reach out to us. If you are a university or government lab looking for applications for your research projects and tech transfer opportunities, reach out to us. If you are a venture capital firm looking for growth of the companies in your portfolio, please reach out to us. Our email address is techscouting.es@baesystems.com, or I'm sure Yulia or Claudia at Venture Cafe could make the connection. And finally, if you are an expert in a BAE Systems business area and are looking for disruptive external technologies in the commercial market to bring new strategy, new capabilities to our products, please contact us. The Tech Scouting team includes 4 full-time Tech Scouts and 25 part-time volunteers. We are always open to new Tech Scouts, experts, and volunteers at BAE Systems to join our team to help us in this great path to new strategic innovation. Without further ado, let me introduce you to our first speaker. Unfortunately, John Watkins was unable to join us today, but we are thrilled to have Shanna Owens here with us. Shanna is the Director of Business Development for the Precision Strike and Sensing Solutions business area within BAE Systems Inc. Electronic Systems sector. Her experience ranges from satellite remote sensing, EO/IR sensor technologies, as well as head-up and helmet-mounted displays and various other sensor technologies. Shanna's role as BD Director is to provide strategic vision to her team and the business area for finding new pursuits into the integrated precision strike portfolio that deliver commercial sensor solutions to the US and its global allies. Shanna has nearly 2 decades of cross-functional and program delivery experience with a broad understanding of BAE Systems electronic systems sector. Shanna holds a Master of Science in Aerospace Engineering. She resides outside of Boston with her 2 children. With that, I turn it over to Shanna Owens. Welcome, Shanna, and thank you for joining us today.
Thank you, Bahare, for that welcome. I appreciate it. First, I want to welcome everyone and thank you for giving us the opportunity to speak at the Adventure Cafe. Before I jump into giving everyone an overview of BAE Systems, I want each of you to know the important part you will play today. Sharing knowledge and diversity of thought is a huge part of our culture, and it allows us to work more efficiently and effectively, which is why collaboration internally as well as externally is so critical to the work we do. Next slide, please, Megan. As you listen to the Precision Strike presenters today, listen for those opportunities to collaborate with us. I've made note of some examples here, but I know that there could be uncharted opportunities to team with each other. So listen to your presenters today as they elaborate on and detail potential areas of collaboration over the next hour or so. Who knows, you may uncover an opportunity we've not thought about, but some of what we'll talk about today is processing, microelectronics, thermal management, low-cost sensors, algorithms, and additive manufacturing, to name a few. Next slide, Megan. Circling back on BAE's culture, everything we do is in support of the mission. For the Precision Strike team, that mission is we protect those who protect us. This mission is tied to our customer programs and instills a sense of belonging and a promise that we will do the best job possible in order to deliver our products into the hands of our customers. Next slide, please. If we look at where we fit in the global industry, we are a top 10 US prime contractor. We have presence in more than 100 nations, and our 2019 sales equated to about 26 billion US dollars, with an order backlog of $58 billion. BAE Systems Inc. is a portion of BAE Systems PLC. In 2019, we had a sales of approximately 11.4 billion, with major operation in 30 states in the US, as well as in the UK. We have on the phone call today, and we also have locations in Sweden and Israel. We are a US company, and we are incorporated in Delaware, and we do have a special security agreement in place so that we can do business as a separated unit within the United States. Next slide, please. As previously mentioned, this is a flow down of how we fit into that global business. Go up, thank you, Megan. In regards to the UK business and BAE Systems writ large, we are 85,000 employees strong. If we look at just the US portion, we have more than 35,000 employees. And as we neck down to the sector that we're speaking about today, which is electronic systems, we're at about 15,000 employees. If I go to the next chart, you'll see that where we fit in Precision Strike in terms of the electronic systems sector. What I want to point out is at the center of this is something that we have called Fast Labs. Fast Labs is our innovation and growth cell. They're really focused on the research and development and reach out to all of those other parts of the business that you see surrounding it. What is circled on the left is our Precision Strike and sensing solutions. We are a very collaborative group in terms of how we operate within electronic systems, and we work across the business areas. So we have a lot of capability even beyond what you see today to work across those teams and to tap back into what we have offering in Fast Labs. Next slide, please. And also, this just gives an idea of how geographically diverse we are. You can see that we are across the country, and we actually just recently acquired a new business that you may have heard of in the news. Collins GPS business is now part of our Precision Strike portfolio called Navigation and Sensing Solutions. They provide a lot of the GPS technology that goes across airborne, ground, and space systems. We won't be going into great detail about that today, but certainly that's something that we invite any questions on for the future. And as I mentioned before, part of our business does have locations in Israel, the United Kingdom, and as well as Mexico City. And finally, hitting upon my last slide today, I want to give everyone a high-level understanding of some of the products that Precision Strike has in its portfolio. We develop high-performance imaging sensors with electro-optical components and thermal sensors and focal plane arrays to support a variety of applications in the defense, dental, civil security, science, and industrial markets. Our area leads the export of global avionics subsystems and associated test equipment, support, and sustainment. We are thought leaders in the application of seeker guidance and control technologies for precision munitions. I'd like to take a moment and just walk you through the pictures that you see on the screen, starting from the top left. The top left shows one of our cornerstone products that's been around for well over 2 decades, which is the THAAD missile, and we provide the seeker guidance for that. Next is a really amazing image that came out of our thermal sensor camera. And then what we see on the far right is a light heads-up display that goes in the cockpits of many of our avionics. Bottom left shows our thermal core sensor, which is the Athena 1980 out of our Lexington Business Center. That center picture of the jet is Taiwan's advanced jet trainer, which we have, we did a first flight this summer and we have our avionics on there. And then finally, you do actually see our GPS receiver card that I mentioned in terms of our most recent acquisition with Collins GPS, again, navigation sensing solutions. At this time, I want to once again thank you for the opportunity to listen to us today and listen over the next hour or so to our various speakers and engage with them about the questions that you may have. I want to really foot stomp the idea that this is about a collaboration and about future opportunities that we can engage with you, and how can we get more embedded into the community. Thank you again, and I'm going to turn this over to Gil Gonzalez. Thank you.
Thank you, Shanna. I always learn something new when I see a presentation from one of our BAE colleagues. There's so much going on. So good afternoon, everyone. My name is Gil Gonzalez. I am the FAST Labs Technology Scouting Program Manager within BAE's Electronic Systems sector. I am your moderator for the next series of speakers. If you have a question, please identify the speaker's name with your question in the Q&A feature. So let's begin with our first challenge statement speaker. Robin Decker is the director of the Lexington Business Center and Sensor Solutions for the Precision Strike and Sensing Solutions business at BAE Systems. In this role, Robin is responsible for managing operations of the Lexington, Massachusetts and San Jose, California sites, and the strategic growth and execution of the visible and thermal sensors business. Robin has worked for BAE Systems for over 20 years in a variety of roles for 5 different businesses across the United States and United Kingdom. Robin has served in strategy and growth, program management, business development, and engineering roles during her career. Robin holds a master's and bachelor's of science in electrical engineering from Binghamton University. She lives in Nashua, New Hampshire, and in her free time, she serves on the board for the nonprofit organization Girls Incorporated of New Hampshire, practices yoga, and enjoys learning about wine. Welcome, Robin.
Good afternoon, everyone. Gil, thanks for that introduction, and I really appreciate the opportunity to spend about 10 minutes or so talking about our CMOS image sensors. I plan on giving an overview and allowing some time at the end for some Q&A. Next slide, please. So our business in San Jose, California, focused on visible image sensors, is right in the heart of Silicon Valley. We're actually celebrating our 100 years of being in business. And we've been in Silicon Valley from really the time of creating Silicon Valley. We were part of the original Fairchild businesses that created Silicon Valley back in 1920. And throughout the years, really established ourselves as the leading edge business creating technology in image sensors across multiple different market domains. As you can see, in 2011, we were acquired by BAE Systems. And from that time, we've been putting out our CMOS sensors, as well as continuing to grow our dental X-ray business. Next slide. So we serve several different markets. Our CMOS sensors are really focused on serving the surveillance and night vision markets, the pro video markets, scientific camera and industrial markets. And then I did mention the dental x-ray markets. And so we do put out x-ray sensors with our CMOS and CCD technology, focused on both extraoral x-rays and intraoral x-rays. Next slide, please. So our sensors, you can see on the slide on the photos on the right there, are really large format sensors. And we're really focused on large format, high resolution sensors. The picture on the bottom, at the bottom right of that slide, is what you would see typically in our cell phones. And there are plenty of low light CMOS camera sensors in cell phones. But we're really looking at really getting a more refined, exquisite image that has ultra dynamic range, has the really good low light performance running at a high frame rate with really low read noise. And all of those characteristics and performance that we bring into those sensors really make them optimal for the different markets we serve. The high frame rate, the wide dynamic range really helps in the pro video market, the high value security and surveillance markets, the low light sensitivity with extreme low light performance, low dark current, excellent color fidelity, really helps in the scientific camera markets, as well as certainly the pro video markets, and where we're looking at going in serving low light night vision markets. Next slide. So we do have a fairly large product line. The photo on the right is a stack up of what a dental x-ray sensor is. We normally don't get to play around with visual image sensors, CMOS sensors. They're really hidden inside of what would be a much larger camera or systems. But I'd like to think most of us have gone to the dentist in the past couple of years. And certainly if you've had x-rays at the dentist, you would probably have had a digital x-ray, although some people might be old enough to remember what it was like to actually have a film x-ray done at the dentist. But on the right-hand side is that sensor that actually goes into your mouth to take that digital x-ray. And in there has our CMOS sensor, as well as scintillator technology, electronics boards in order to translate the image that would go onto the screen, as well as obviously some product design packaging to make sure that when you bite down on that sensor, you're not actually breaking the sensor. So that is what our intraoral dental x-ray sensor looks like, and I would put money on that. A majority of the people on the phone have actually had one of our sensors in their mouth sometime in your life. In terms of our commercial imaging sensors that go into visible image cameras, we do have a set of products across our family that have different levels of resolution, lower resolution sensors, 4 megapixels all the way up to 12 megapixels, different optical formats, which are really focused on what the target market is and what the camera is actually going to be used for. Most of our sensors come with a color or monochrome option, and then selectable frame rates. And as I mentioned on the previous slide, the different frame rates really are focused on what the actual use is for that sensor. The higher frame rates really much better for video, pro video. When you get to the lower frame rate, you're really talking about very sensitive type of imaging that we're trying to do at the lower frame rates. We have a variety of different pixel sizes, and the pixel sizes obviously help with the footprint of the large format sensor. And the larger the pixel allows us to bring in more light, getting the potential of having a better low light performance at areas of really low areas of having low light, obviously low light environments, ambient lighting. Next slide, please. So where are we headed? So we have our products that we're out selling today being built into cameras all over the world. Where we're really focused on is we're pushing the technology and our low light performance to be able to start replacing analog low light devices and night vision goggles to create a full digital goggle. And we're really focusing on, as you can see in the soldier and what the warfighter needs, and providing them the best imagery that we can when they go in to perform their operations. We're really going to help enable with digital night vision, augmented reality. So there's a single piece of glass with a sensor that allows a user to be able to do what we do today on, on lots of our video games. It allows us to connect to different networks and allows for easier system integration using the digital night vision. We're also looking at ultra-low noise scientific imaging. So I talked about servicing the scientific camera market, the industrial camera market, and we're really breakthroughs and pushing technology in our low-level noise performance. And this low-level read noise that we get on our sensors enables true photon counting for life sciences and physics research. And so we're really excited that the ability to get the technology down to that level of read noise really enables our customers to be able to do huge breakthroughs, what we hope will be transformational changes in those areas using our sensor, and also being able to take that technology and fold it into other markets. We're also looking at reducing power and size of our sensors. I did mention that they are large format sensors, but as we get advance our technology, we want to have high resolution sensors with really high performance pixels that we can scale down to reduce power and size of the sensor, allows it more opportunities to get into lots of different types of cameras and systems. Certainly, they are out on the commercial market in the different areas that we've talked about. So our sensors are in pro video cameras that are sold out in the market today by some of reputable, not small businesses, but larger business pro video camera manufacturers. Scientific cameras, we are have a pretty large footprint, a very large footprint in that market, and companies that create cameras for the scientific life sciences market are probably selling a camera, at least one, if not many cameras with our sensors in it today.
Okay, great. Thank you. Let's see. Here's another question. Are there thermal concerns with these sensors that you have novel solutions for? I mean, there's obviously, if there's anything there, I would say it's probably IP, but I would say around that question, are there, I think you mentioned some challenges earlier. Is there anything around the challenges that you would want to elaborate on?
Sure. So certainly as we want to be able to bring in as much light as possible to create the low light performance that we get with as the largest pixel that we can in the size footprint, as we get to higher resolution sensors, clearly we're going to dissipate more power. And what we really want to bring to our next generation of systems is a smallest footprint as possible with as much image or performance that we can get out of it, which creates trying to find the optimal amount of power to be able to go into a camera. And so today, as we sell our large format sensors, the camera manufacturers, the OEMs, design our sensors in with the amount of cooling that's needed. As we look to get into more portable systems, finding more novel ways and innovative ways to dissipate that power or to reduce the power on the silicon inside the package is really what we need to do, because they won't have all of the opportunities or levers to be able to cool our sensor in the cameras with the level of performance that we're looking for.
Great. Thank you, Robin. And I'll say we'll close this out with one more, and I think this is a general question, not necessarily just for you. And I'm gonna kind of, as in asking this question, I am going to reply back to the person asking the question. In what regard? They're asking, how do we collaborate? I think there are many ways within BAE to engage and collaborate. If you want to just touch on some of those avenues.
Sure. I think the first step would really be reaching out to us. And I think at the beginning, Bahare really went through the best ways to contact us after this event. And certainly we can follow up if there are areas for collaboration. I think there's lots of different ways we can collaborate depending on what the technology is that we're really looking to do, and are we looking to create products, integrate different technology, share our technology. I think there's probably multiple different ways, whether it's through different types of small business contracts, sharing research and development, dollars and funding in order to generate something together, or going out and proposing something together to one of our targeted customers, and again, depending what problem we're trying to solve.
Great. Thank you, Robin.
Okay, thank you.
Take the time. So we'll move on to our next speaker. Kevin Grealish is our next speaker. He is the technical director of our Lexington Business Center, where BAE Systems provides industry-leading uncooled thermal sensors to internal, commercial, and military customers. Kevin is responsible for identifying and maturing new technologies and providing technical guidance to our project teams. He's one of our smart guys, really smart guys. Okay, so welcome, Kevin.
Thank you, Gil. Let's see, I am trying to turn on my video here and I can't, which I'm finding to be really disappointing because I actually put on a shirt today. But, oh well. Let's see. So hi everybody. Thanks for joining us today, and thanks for taking some time to let me share what we're doing in the uncooled thermal imaging area. Next slide, please. So so thermal imaging. What we're doing is forming images of that part of the spectrum that comes from objects at terrestrial temperatures. That is, the temperatures that we experience in our lives day in and day out. And so we call it thermal imaging because it's coming from the temperature of the objects. In a very real sense, we're measuring temperature by measuring the light. Traditionally, thermal imaging has required cooling sensors down to cryogenic temperatures. And that means what comes along with that then at the system level is oh, here we go. We're getting a picture here. At any rate, at the system level, operating the sensor at cryogenic temperatures means adding cooler. It adds weight, it adds power, it adds size, it adds cost. In an uncooled sensor is operating at room temperature. While the performance isn't the exquisite performance that you would get with a cooled sensor, the cost, the size, the weight, the power is substantially less, and there's a lot of applications where this is just a great fit. So within the uncooled marketplace, we cater to that part of the market that is interested in very good imagery, high sensitivity imagery, high resolution, very high resolution requirements, and just all around good imagery. We've been making uncooled imagers since the late 90s, and today we'll ship 30,000. We expect to ship about 30,000 sensors this year. So we're located in Lexington, Massachusetts, and within our facility, we design the readout integrated circuits that our sensors use. We design the pixels themselves, and we actually fabricate the pixels in our factory. Our readout ROIC, sorry for the acronym soup, folks, custom ROICs here. So readout integrated circuit So we offer that. So we have that capability not only for our uncooled sensors, but we also develop readout circuitry for low light applications that Robin had just mentioned, and cooled sensors as well. Next slide, please. Okay, so here's an image from our HD from our TWV 1920 camera. This is true HD video, 1920 pixels horizontally, 1600 pixels vertically. And what you're seeing in the image, the bright areas of the image, those are the warm parts of the image. The dark areas of the image are the cool parts. And so here you see the shadow here, the tree. It's a very sunny day, and so you can see how the asphalt here has warmed up the parts of it that are exposed to the sun. And coming into the upper right here, we're just zooming in. We're just zooming in around this light stanchion, just to give you, and just showing this to give you some sense of the high resolution that we get out of this sensor. In the lower left, you can see some interesting aspects about thermal imagery. The truck here, you can see that little white horizontal bar in the truck. That's the muffler. Why is the muffler white? Because it is hot. So the truck that truck has recently been operating. Oh, look underneath the truck here. That's pretty. That's not a whole. Underneath the truck, it's pretty warm. So that truck hasn't been there for very long, right? The asphalt hasn't had a chance to cool yet. Take a look over here at this truck off to the right. The asphalt's much darker, and so that truck has been there for a while. Next slide, please. Oh, okay. So I keep saying that we've got stunning performance. What's that all about? Okay, so back in the late 90s, we started with a pixel size of 46 microns. That has been shrunk over the years in successive steps. We offer a 12 micron pixel to the market today. We were the first to reach each one of these intermediate steps, and we've been producing our 12 micron technology since 2012, actually. The advantage that we have in our design is that we have a single layer construction of the pixel itself. I won't get too technical here, folks, but that single layer construction is really important because it's easy to make. Because it's easy to make, we have very uniform imagery. We have very high sensitivity, very, very sensitive imagery, and good yields in our factory to provide very affordable sensors into the market. Next slide, please, Gil. I'm sorry, Megan. Sorry. Okay, so what are we doing with this technology? Here we are on the left. We have two sensors that we offer to the market today: a 640 by 480 60 hertz sensor, and down below our high resolution. We just saw the images of those. We just saw the images from that sensor a few slides ago. 1920 by 1200, operating at 60 hertz. Both of these we're driving, again, we position ourselves at the high-end performance of the market. And so in both cases, we continue to drive performance into the product. We are working on a technology now, wafer level packaging, that is going to take the size of this package and shrink it down dramatically, make it even smaller. And along with that small size then comes a real cost advantage, a very interesting cost advantage that comes with it. And let's see, in addition to our 640 and our 1920, we are also developing an SXGA resolution sensor, 1280 by 1024, to kind of fill out that middle part of our quiver and provide customers, a full suite of resolutions, so that they can pick just the right one for their application. Okay, looking to the future, we're working very hard on next generation technology. That next generation technology is going to drive our sensitivity. I keep talking about that sensitivity. Just pause for a minute. What does sensitivity mean? That means, you can think in terms of, I've got two objects next to each other. the objects are at different temperatures. What kind of temperature resolution, what kind of difference in temperature resolution can I see? Well, we're going to drive that. Temperature sensitivity to levels that we just haven't seen, that no one has seen in uncooled to date. Along with that comes a faster frame rate and in a very wide dynamic range. Okay, really interesting. What this means is that cooled sensor market that I talked about, those cooled sensors, we're going to be able to go toe-to-toe with some of those cooled sensors. Hey, there's still going to be a market for the really high-end stuff, but there's a large segment of that cooled sensor market that will likely get disrupted when this technology becomes mature. Next slide, please. Okay, great. So collaboration areas, just talk a little bit about that. We're really into performance image, high fidelity images. Very good imagery is important to our business, and so image processing, novel image processing capabilities are always interesting to us. There's uncooled imagery has a very broad dynamic range to it, and so enhancing the contrast in that imagery is important. So driving the noise in the image down, driving sensitivity down, and so algorithms associated with that. And also, we're very interested in folks that have capability around correcting the uniformity, improving the uniformity by using the information that's in the scene itself. So we've got a read. As I said, we have a readout integrated circuit capability, development capability. We are always interested in collaborating with other folks with novel approaches to that. And so if that's an area of expertise of yours, please feel free to get in touch with us. On the electronic side, low SWaP, sorry for the acronym again, size, weight, and power. So driving imaging electronics, taking advantage of modern technology there to drive out, to continue to drive the size and drive down size, drive down power. Microelectronics packaging, right? Again, it's another area where we're interested not only in miniaturizing the electronics end of it, but how all that comes together into the mechanical package itself. And finally, passive cooling. So we are a low power device, but you still need to deal with the heat. We still generate heat, and that has to be managed. And so, folks with expertise in that area, love to hear from you with novel ideas that you have on that area. And I think that brings us to the question time. So please, folks, what would you like to know about?
Great, thanks, Kevin. You can leave your video on so that they can see you answer their questions. All right, so looking for some new questions to come through. Another challenge here. I gave us a whole lot of questions for Robin, so let's see what we've got for Kevin. I didn't see any new ones come through while you were talking, so
okay.
I'll see if they
no
come
worries.
through here in the next few seconds. So one question comes through, is image recognition of interest?
Yeah, that's a really great question. So, within our business, within Lexington, our job is around creating the imagery. We work with other parts of our businesses that have a lot of interest in image recognition. Do we have someone from Precision? Well, of course, we're all Precision Strike. So if you've got capability around image recognition, we'd love to hear from you.
Thanks, Kevin. Somebody asks, are we specifically looking for real-time non-uniformity correction? That's something you can talk about.
That is exactly what looking for. So, you know, one of the things that limits our sensitivity is, as good as we are, each pixel has a little different response from its neighbors, and that presents to the user as noise and limits the user's ability to see really fine detail. And so, yeah, traditionally the way this has been dealt with is to include a mechanical shutter into the camera. And the idea is that you close this shutter, you have a uniform image, and your processing electronics then takes that image and creates a correction to give you a nice uniform scene. Yeah, so in the scene-based non-uniformity correction, what we are doing there is removing the shutter, the mechanical shutter from the system, and just using the information in the scene itself to create that uniformity correction.
Great, thanks, Kevin. We still have some time for a couple more questions here. I see one here, and we can come back to some of these at the Q&A. That's a little bit later too. How sensitive for cross-span images such as wires, and at what ranges if traveling at rates like 100 miles per hour? So,
yeah. So I guess I would say that our sensors themselves, we're producing sensors with a 50 millikelvin sensitivity, right? At the sensor level. What happens at the camera level has a whole lot to do with the optics design, yeah, and so what happens there at the camera level is related to really in the end the optic that we put in front of the sensor.
Yeah.
So the field of view, the aperture.
Yep. Yeah, and I agree with you, Kevin, on that one. And you know, I have some background in that area, and I'll say, yeah, it's not just the sensor. It's right. The sensor has its sensitivity. You've got the optical system, and such that plays into that, right? So, what type of materials you're using for optics, what kind of design you have, what kind of thin films you have on your optics and such. So all that inside, right? So
a bit of a not to give the questioner a non-answer, but it's you know it's really the system designer that's got a lot of flexibility there in configuring his system to drive to the particular requirements that he's trying to meet.
Well, great. Thank you, Kevin. Appreciate it. We're going to move on to the next speaker. So we still have other questions, but we can bring those up a little bit later. Okay.
Great.
All right. So our next speaker is Chris Forrest. He is the Innovation and Growth Lead for the BAE Systems Electronic Systems Rochester Business Center in the UK. There, he leads the innovation and growth team of technology managers that work across the product lines to maintain comprehensive and consistent technology strategies, developing and exploiting external technology relationships, and acting as ambassadors for technology intelligence. Chris has over 20 years of experience with BAE Systems. Welcome, Chris.
Thank you for that introduction, Gil, and hello to everybody in all the different time zones. It's good evening from me, but good afternoon to most of you. I'm going to talk to you about our advanced display products, and these augment humans in their use of our increasingly complex machines. So next slide, please. Okay, so firstly, an introduction to the Rochester Business Center, and we call that the RBC. This is in the southeast of the UK, in a country called Kent, or county called Kent, which is referred to as the Garden of England, although if you live there, you probably wouldn't call it that. We have around 1,500 employees on site who design, manufacture, and support our black box products for both civilian and military platforms. the RBC has several product lines across 3 different electronic systems business areas, but the product line within the Precision Strike business area is called Advanced Displays and Services, ADS. As the name suggests, this product line consists of our advanced display products, and we've been making these since 1959. So nowadays, these displays are referred to as augmented reality displays. So in effect, ADS has been designing, building and delivering AR solutions for military and civilian applications for over 40 years. Next slide, please. Okay, so when we talk about humans and machines, we predominantly focus on the interface between them, and we call this the human-machine interface, HMI. And an HMI is really any interaction in which information is exchanged between a human and a machine, or a machine and a human, using a cognitive or physical method. So for example, sight, sound, and touch. Building a good HMI relies on understanding our physical, behavioral, and mental capabilities to provide a realistic and intuitive interaction, both physically and virtually. And with virtual visual interactions, we are exploring mixed reality displays consisting of virtual cockpits and dashboards. So like display screens, but fixed in the user's field of view, alongside the conformal graphics that are geospatially referenced to the outside world. And by this, I mean they remain overlaid on a geographic position, regardless of where the head moves to. Managing the cognitive load of a user as the complexity, capability, and the autonomy of our machines grow is key to ensuring we can still reap the benefits of a good HMI. And these benefits are rapid acquisition of skills with less training and aptitude requirements for entry, a reduction in the number of operators required and the number of human errors that may result, a high system and user efficiency, increased user acceptance and comfort, a reduction in physical and mental stress, increased cognitive capacity, and generally safer operations. Next slide, please. So within ADS, we specialize in developing advanced HMI solutions that provide natural, intuitive, and deep visual and oral interactions with machines in a wide range of military and civilian applications. We are prototyping, designing, manufacturing, and delivering products that pave the way for tomorrow's flying air taxis, unmanned regional jets, self-driving buses, and autonomous rail networks. Next slide, please. ADS's core products are deployed globally across military and civilian applications and break down into the 3 areas shown on this slide. At the top left, we have our head-up displays that we call HUDs. These were originally designed for military aircraft pilots, and our heritage of building HUDs for so many years means that ADS knows how to build high-performance displays that provide the user with the information they need without overloading them. HUDs present augmenting information in the user's field of view, overlaid on the outside world that is still really important to them. The information can be fixed in position, so for example, airspeed readouts, or it can move as the platform heading or direction changes to remain geospatially located and conformal to the outside world, for example, a navigation waypoint. So at the top right, we have our head-mounted displays, HMDs. The HMD was a natural next step from a head-up display. It's just one that's attached to the user's head instead of the platform or the vehicle. So the conformal outside world information moves as the head position changes. This tracking of a head allows for line of sight cueing and commanding, as well as an ability to have augmented visuals wherever you look, not just in a fixed forward view of your platform. Like with our HUDs, our HMDs are designed to be high-performing displays, able to present augmenting information within the user's field of view, whilst leaving the rapidly changing outside world view perfectly visible. The added capability here is with the head tracking, often on a moving platform and with varying extremes of lighting conditions. Our HMDs can also include 3D audio systems for a deeper HMI, which gives you spatial awareness and extra cueing, and this can be deployed in various form factors and different attachment systems. And then finally, at the bottom, we have our core computing products that generate, process, and manage the information that's sent to our display heads. Depending on the application, this might be aircraft electronics that we call avionics. It might be person-worn computers. It might be vehicle-mounted management computers, or even ship-borne processing cabinets, for example. So the current applications for our products are predominantly military fast jet, military rotary wing, and civilian air transport. But examples of some of our future adjacent markets are first responders, security forces, air traffic control, a ship's bridge, public transport, and precision medical operations. Next slide, please. So we spoke about good HMI and the benefits that this can bring. And through our experience and engagement with end users over the last 40 years, we've identified the primary characteristics of good HMI for complex and autonomous systems of the near future. So the first of these relates to the increasing employment of artificial intelligence, AI, and machine learning, ML, in our processing. Within the HMI, we see AI and the learned behaviors that the ML gives you. They're able to predict the likely end result from an emerging situation, and they can provide context-sensitive information that's prioritized or selected from a whole series of data relating to numerous interrelated events within that scenario. What this does is ensure the user is only presented with the information they need to see to act, and it reduces their cognitive loading during very stressful events. With this increased autonomy, we need to grow the user's trust in machine speed decisions and be comfortable with those decisions being made. This trust must be built up and earned, just like between humans, and a good HMI will be able to visualize or otherwise explain the actions that a machine has just taken or is even about to take. So the user always feels in control, he feels like he's overseeing, and without stress or concern that the platform may be malfunctioning in some way. Increasing augmentation must remain usable, wearable, and durable above all else. So with usability, we're referring to the intuitive operation that gives you the natural augmentation and a tangible reduction in cognitive loading and physiological stress. With wearability, we're referring to the worn weight, the center of gravity, how it sits on the head, the compatibility with any personal protective equipment, and the optical performance. So this should minimize or even eliminate any eye strain, occlusion of the vision, any muscular strains or skeletal damage. With durability, the display must be fit for purpose and able to withstand the environmental and usage forces it will see across its lifetime, all while maintaining its full performance. So examples of these three characteristics of usability, wearability, and durability in an ADS product called iBar, which is our AR glasses, is shown in the infographic at the bottom left. It's got a lightweight design, it's capable of operating in harsh environments, a clear color, symbology and even high brightness, on the move platform performance, and a 40 by 30 degree wide field of view. As another example on the top right, and this is within an aircraft environment, you have the three good airmanship rules of aviate, navigate, and communicate. So in a stressful emergency environment, the HMI must still conform to this framework and assist the user to fly, the aviate part, assist the user to avoid terrain still, so the navigate, and assist the user with telling others about the emergency situation, the communicate. Future HMIs will achieve this autonomously and will be trusted to do so by the user. Next slide, please. So let's look at the technology enablers for these future characteristics and the areas for potential future collaboration. And firstly, we'll look within the electronics and optics. So to allow further form factor reductions that minimize the vision occlusion and improve this usability, wearability, and durability, we're constantly pursuing compact electronic designs, packages, devices, and manufacture techniques. And within this ever-increasing small form factor, we are continuously identifying and trialing alternative waveguide approaches to maintain our full color high-performance display with our large iMotion box, large depth of field, and our wide field of view. To reduce cable weight and snagging hazards, as well as providing anti-tamper and anti-spoofing benefits, we're investigating secure wireless data and power interfaces. To ensure our high-performance displays have a low power consumption and therefore low thermal output, we're also researching high-brightness, high-efficiency, small form factor light sources. And for a person-worn advanced display that can do autonomous processing with still that maximum usability, wearability, and durability, we're looking to build high performance compute platforms, and again with that low power requirement and low thermal output, so it can be person worn. Next slide, please. So the second set of technology enablers for potential future collaboration is within the sensing. So we're working on integrating eye tracking technology with biometric sensors. So for example, heart rate, perspiration and respiration, for example, that monitor the user's stress level, and it can help prioritize the information based on the complexity of the task, where the user's attention is and the situation at hand. We are building on our 3D audio capabilities for spatial awareness and audio cueing to enable a deeper HMI with high performance voice control and advanced active noise reduction technologies to allow that direct voice control to work even in very loud environments, if you think like a rotary wing platform, for example. To expand the augmentation of the display, we're researching high performance enhanced human vision systems that use novel computer vision sensors, analytics, processing and data fusion algorithms. And to build on our highly accurate head tracking techniques, we research reliable and durable free space tracking and localization solutions that will maintain this performance across all lighting and environmental conditions. Next slide, please. So in conclusion, BAE Systems Electronic Systems is identifying, nurturing and developing novel technologies and ideas within augmented and mixed reality displays to continue to innovate and develop tomorrow's advanced HMI products. These are needed for the ever-increasing complexity, capability and autonomy of our future civilian and military systems. We look forward to hearing your pitches in some of the technology areas we've discussed today, and now we can cover some of your questions. Thank you.
Great, thank you, Chris. I'm looking forward to using some of that technology when I drive at night. So if you can send me something, you know, one of these days, I really appreciate it.
Yeah.
Folks, go ahead and send your questions through. We had one come through while you were talking, so I'm going to start with that one while others are typing away. So this one has to do with location of work. Where are we really developing this HMI specific technology?
Yeah, predominantly the work across our HMI products is within the UK at present.
Okay. So this may be a challenging question, but maybe you'll know better than I will. How can augmented HMI increase an individual's cognitive capacity if an individual's cognitive capacity is actually limited physiologically?
Yeah, it's a good question. And obviously, there will be limits to our cognitive capacity, and that will vary. One of the things we're also looking at is to try and bring in gamification to our technologies, and that means when you bring in a pilot or a user to try and train them in a task, you actually identify through gamification techniques their actual capacity to learn and the speed at which they're going to learn things. So in that way, you can tailor training courses and actual development based on their unique capability. So that question brings up a very good aspect of our cognitive capacity. It is very unique and very dependent on that user. So yeah, that's why we need the extra biometric sensors and that eye tracking technology, so that during the early days of a user's training, you can assess that aptitude, assess that capability, and tailor the training.
Great, thank you. It looks like you piqued somebody's interest. They're saying, how can undergrad students in the UK get involved? Somebody's excited.
Yes, that's good news. Yes, we have a very good apprenticeship program in the UK, and I definitely can put people in contact with that. So yeah, I'll take names at the end and make sure we can tie up. We're always on the lookout for new engineers.
Sounds great. Well, so whoever's asking that question, right, here's an opportunity. Get your name in there so that Chris will know, so that maybe you can route it to the right folks to get some students involved. Great. Looks like that was all the questions that we had for you at this time. So appreciate the time and appreciate you staying up for this. So
yeah, you can't see the matchsticks, but no, it's only 9 o'clock. It's fine. Yeah. Thank you for your time.
So all right, so we'll move on to our next speaker. Thank you again, Chris. Okay, our next speaker is Tim Southward. He is the Deputy Site Executive and Program Manager for BAE Systems Electronic Systems in Huntsville, Alabama. He is responsible for growing and supporting BAE Systems business near strategic customers at the Redstone Arsenal and surrounding areas. He is also the Program Manager for a strategic guided munitions technology development. Tim is an integrator of internal and external technologies to develop packaged systems and subsystems for defense customers. Welcome, Tim.
Thank you, Gil, and welcome to everyone this afternoon. I want to emphasize a couple of points that you made in terms of the introduction. I am in Huntsville, Alabama, and that is where we hear the voice of the customer. We're here to hear what they're having to say about their needs and their missions. And also that we are an integrator of technologies, and that's both internal technologies as well as external technologies. I really encourage my engineering teams to take a look at the trades between what we have inside as well as what we see on the outside. And also here in Huntsville, we are very much a package center system developer. What we give to our customers and how we integrate our products are the subsystems and systems that we deliver to our customer. Next slide, please. And so what we've noticed here is that there is a collaboration, a bridge between defense and commercial technologies. In the past, that has been strongly in one direction as we've observed. But in the last 10 years, there's certainly been a two-way collaboration between the defense organizations and the commercial entities. And what we see happening here is there's an innovation engine that takes place. And these innovations that are taking place are making things smaller, they're making things better, they're making things faster and cheaper. And so we recognize that in this technology bridge that it is important for us to partner with our technology members, both again from the internal as well as from the external of our organization. Because at the end of the day, we're yielding innovations that are good, not only for people on their everyday life, but also in the work and the missions that we perform together. Next slide. And so precision is, it carries a lot of weight in the sort of things that we do, especially in precision strike. And the point of this particular discussion is that precision technologies are all around us. And GPS, for example, is one of those technologies that was developed for a defense purpose and actually improved and made more efficient with the use of collaborating with commercial entities. And so GPS, other technologies such as GLONASS, all of them are developed for military purposes. But again, in the technology transfer over the bridge, we've allowed technologies to become a lot smaller, again, a lot more affordable and cheaper for use. And so this innovation has developed things that we value. I don't know how many of you remember when the GPS receivers were first introduced into the marketplace. I was one of those that went out and bought one for my vehicle. And then it mattered to me as I was traveling across the country to do the different jobs that I was asked to perform. And so I was certainly willing to invest in that technology. And then I've also been one that have been expecting what's the next innovation that comes to bear. And today I wear the GPS receiver through my watch, and I'm able to take advantage of that technology every day. And so as we go through and we look at what technologies enable the sort of things that we do in our business, precision carries a lot of weight. And it is that precision technology that we value, that we want to invest in, and that we're willing to wait for. And this is the same thing that our customers are certainly expecting as well. They value the sort of technologies that we bring to bear. They're willing to invest in that. And they are always pushing us to what's the next innovation that we can bring to bear. And so in the example of the GPS, again, those GPS receivers were very costly when they first were introduced to consumers. They then began to get smaller to where they fit into cell phones. And again, today we have them in our Apple Watches if you have one of those. And people are continuing to ask the questions, how will the innovation, what is the next innovation that will come out of this area? And people are already beginning to use it for autopilot and navigation of autos and ships and planes. And so it's that questioning of the technology that allows us to do things better, again, more cheaper, and in smaller sizes than ever before. Next slide. And so again, precision is very important to us in the missions that we conduct for our customers. Precision is demanded in the sort of products that we build that defend our nation against ballistic missile threats. Precision is demanded when we protect the platforms from enemy attack. And then precision is also demanded when we protect our warfighters. All of these things that we do with our precision technologies are taking into consideration the environment that we must work. When we're looking at the sort of products that we deliver to our customers, we have to deliver them under situations of high shock and thermal survivability. We have to operate in day and night and all weather conditions. When we're looking at navigation, we're looking at multi-mode capabilities, EOIR, RF, and even LiDAR. We're looking at algorithms and technologies to help us with search and identification and detection of targets. And then we're also up against environments where in many cases it's GPS denied. All of this, we're asked to do it in low cost and again, in smaller and smaller sizes, asked to do a lot more with a lot less. But it's because of that, that precision is very important to the sort of products that we deliver. And it's demanded to meet the mission that we have all of the time. And that mission is that we protect those who protect us. And not some of the time, but all of the time. And that's why precision is so important to us in the things that we do. Next slide. And so what are the next innovations in the precision delivery systems that we're looking at? We're looking at technologies for low-cost sensors. We're looking at algorithms, processors, and control actuation systems. And so I wanted to take one of those as an example. As we go off and perform navigation, we can use any different types of means, EOIR, RF, or other modalities. And so those technologies where it matters in terms of the size, how much power they're using, we're always looking for the innovation that will help us to do our job even better and again, in a much smaller size. Our enemies often look at the regular patterns that they would expect out of our systems. And so what are the innovations in artificial intelligence and game theory that would allow us to make those patterns less predictable so that we can do our job even more effective. In the area of processors, we're looking to make things faster and again, smaller in the sort of processing, especially when there's a lot of graphics that's involved in the missions that we perform. And so again, we recognize that working along with industry, and that also includes colleges and universities, working along with you helps us to increase our performance and really unleash that innovation engine that we talked about earlier. Next slide. So what does our mission mean to you? It means becoming a partner with us in innovation. It means also being a partner with us to win. We work a lot with traditional and non-traditional contractors. We do a lot with small businesses that are in the area. Throughout the country, we actually support small businesses through some of the contracts that we have, which have targets for participation for the small businesses. And then we also partner a lot with colleges and universities so that we can, again, continue to build the proficiency and the partnerships as we move forward. And lastly, working with us in terms of our precision mission means becoming a partner in quality. And we have very high standards in the mission that we perform. We protect those who protect us. And so having quality, reliable products all of the time makes a difference. And being able to work together to achieve high levels of customer satisfaction, reducing the costs, mitigating the risks, and then achieving a culture of compliance to all the quality standards that are before us. And so again, we recognize that it is you that allows us to accomplish our mission. It is you that allows us to achieve this bridge between defense and commercial technologies. And so we invite you to participate with us. Let us know your interests. Let us know your technologies through the different venues that we have throughout the country. And we're willing to listen to that and partner with you as we move forward to the missions that we have before us. Gil, I'll turn it back over to you.
Great, thanks, Tim. Great discussion there. Let's see what questions we have. Okay, so got a question. Do you use synthetic aperture radar imagery and inverse synthetic aperture radar imagery? And if you can, talk to applications.
We do use SAR in the performance of missions related to precision guided munitions. And so I cannot get into the details of what we do, but that is certainly an interest area and technologies that we're currently using within the portfolio of products that we provide.
Okay. There's a cost question here. I don't think we can talk to that one. If there are any other questions, throw them out there. All right. Okay. I don't see any other questions coming through, so good job there, answering questions before they can be asked. So what we'll do at this point is we will open up to the broader sense of questions for all of our presenters. I want to thank them all for participating here. So I'll go back through some of the questions that we've had before that we didn't get to, and maybe hit a few of those before we move on to the next segment of this event. So let's see, I want to go back to Robin on a question. I think this one was for Robin. For the advanced 3D sensing technology, are you interested in implementing existing technologies, or really focused on developing new technologies?
Yeah, great question. Actually, both. So we're certainly looking into new image technologies that would help us implement the 3D technology, and looking at ways that we could use our sensors to create 3D technology. So if somebody has something that they want to collaborate on, please don't hesitate to reach out so we can get in contact and see what we can do.
Great, thank you. This one's for Kevin. Kevin, it's a question from Joe Jansen at NBTS. He'd like to know a little bit more about the 12 micron long wave IR.
Let's see, I'm not really sure what to talk about there. Pretty broad question. Hey, Joe, if you want to give me a call, get in touch. Let's set up a time to talk, and I'd love to answer whatever questions you've got.
All right. Let's see. I'm just looking to see if there are any other ones. Let me pull another one out. This one's for you, Kevin. How does noise manifest in the image from a sensor perspective?
Okay, so there are different kinds of noises that you'll see. There are fixed pattern noises that you'll see in the imagery. There's column structure to that. There is row structure to it, and then there's also random spatial noise as well. We're particularly interested in algorithms that can get after row structure, column structure. That is helpful. As far as and then temporal noise itself, you know, there's random temporal noise that you'll see in each one of the individual pixels themselves. They can be frame bounce as well, although our processing pretty much cleans that up. So not a whole lot to be gained there. Yeah. So if that question is around what kinds of things would we be trying to defeat with a scene-based non-uniformity correction? Yeah, those are the kinds of features that those algorithms would be going after.
Great, thank you. I think I've got a general question here. Is there any interest in shortwave IR?
Sure, I'll answer that. There are parts of our company that are interested in shortwave IR and different type of camera technologies, and we are looking at developing sensors. Sorry, my puppy is attacking me here. Looking at developing sensors across the whole spectrum. So I think there actually was a question about near IR optics as well. And certainly our visible imaging goes all the way up into the near IR wavelengths, and then we have the long wave IR, and we are interested in short wave IR as well. Thank you.
Great, thank you, Robin. Okay, so let's see what else. Here's a question. I'm not sure if I fully understand it. That's to Tim. Maybe you'll understand it, Tim. This is, do you have interest in indoor location?
Can you repeat that question?
It says, do you have interest in indoor location? There might be something I missed in the presentation.
Yeah, I don't understand
Okay.
the context of that question.
Okay, no, that's fine. I thought maybe there was just something I missed. It just seemed like an easy one to draw out. Sorry. What else? Let's go for one more. I'm going to pull one out here. Here's another question about, is there any interest in non-CMOS solutions, starlight color? It's probably a Kevin and Robin question.
Yeah, what was that in starlight? Starlight color imagery. That's a very interesting capability if it's available. Sure. Yeah, I mean, it's great. You know, the near IR imagery is great, but when the guy wants to say it's the person in the red truck, it's pretty hard to do that when you've got monochrome black and white imagery. So yeah, that's interesting stuff. So would be, yeah,
Sure.
Be interested to hear about that.
All right. Okay. All right. So I am going to close out our Q&A session part of this. But what I want to do is make a note that if you're looking to reach out, one way that you can reach out is through our tech scouting team. Okay. I'm part of the tech scouting team. So we're not the only way, but we are an avenue, and you know, we're one of the avenues that's on this event right now. So you can send us an email at, if you want to take a moment to write this down for anybody who's ready. It's tech scouting, techschouting@baesystems.com. Okay, and maybe I'll drop that in the Q&A so people can see it, and that way you can pull it. So if you want to reach out, feel free to do that. You know, we can definitely reach out to the folks that have participated here and give them the information that you send. Okay, and they'll take it from there. Okay, I want to thank you all for participating again. Great job, everybody. Love to hear about all the technologies we got going on throughout the company, and it's great to see you all again.